We know impulse equals momentum change, which can be symbolized this way, but impulse is defined as force times the time of an interaction, and change in momentum would be an object's mass times its change in velocity. And the force is the force on an object of some mass for some duration of time, and it causes some change in velocity. Now I'm going to obey the rules of algebra and just rearrange these terms and make a substitution and end up with what's called Newton's second law. First thing I want to do is just substitute in delta V for VF minus VI. And divide both sides by n. Cancels out over there. And now I'm going to divide both sides by t. And divides out there. You'll recognize that change in velocity over time is acceleration. And we end up with acceleration equals the force on the object divided by mass. Let's flip that around and see this. Acceleration equals the force over the mass, where F is the net force on the object, M is the mass of the object, and A is the acceleration the object will experience. It should make sense because in this ratio, as the net force goes up, this ratio goes up, meaning the acceleration would go up. And if the mass were to go up of the object, that would mean it would accelerate less for a given net force. And if the mass goes up, the ratio goes down, meaning acceleration would go down. This and Newton's second law.